Concept on mole, molarity and molality, starting with the mole. Mole is written as MOL. It is the amount of substance. 1 mole is equal to 6.022 into 10 to the power of 23 elements such as atoms or molecules or ions. Here, 6.022 into 10 to the power of 23 is called Avogadro's number. This number represents the number of particles present in 1 mole of a substance. Millimole is written as mmol. It is thousandth part of a mole of a substance. Next is the molecular weight or molar mass, which is defined as gram per mole. It is the mass of 1 mole of that substance. Next is molarity. Molarity is number of moles of solute present in 1 liter of solvent. It is written as MOL per liter. Molality is number of moles of solute in 1 kilogram of solvent. It is written as mole per kilogram. Next concept is about tonicity. Tonicity is the number of effective osmoles that can exert osmotic gradient across the membrane, for example, sodium and chloride, whereas the ineffective osmole, which cannot generate osmotic gradient, is urea. There are different types of tonic solutions. They are hypertonic, isotonic, and hypotonic solution. Hypertonic solution causes water to move out of the cells into the plasma, increasing the extracellular fluid volume and osmolality. It is used to treat cerebral edema, hyponatremia, and severe fluid shift. Risks include cellular dehydration, hypernatremia, and fluid overload. Examples of hypertonic solution are 3% normal saline, 25% dextrose. Next is isotonic solution. Isotonic solution expands the plasma volume without causing the fluid shifts between the compartments. It is used to maintain the hydration. Hydration, replacing fluid loss, example during the surgery, if in dehydration, and when there is hemorrhage. Risks of fluid overload with larger volumes can also be seen. Examples of isotonic solutions are 5% albumin, 0.9% normal saline and lactate ringer. Hypotonic solution, which causes water to move from the plasma into the cells, decreasing extracellular fluid osmolality. It is used to treat dehydration at cellular levels, example in diabetic ketoacidosis or hyponatremia. Risks include cellular overhydration, hypotension, and worsening of cerebral edema. Examples of hypotonic solution include 0.45% normal saline, 5% dextrose, and 10% dextrose. Let us see a few examples to understand more in detail about the molecular mass. Hydrogen. The molar mass of hydrogen is 1, so it is written as 1 gram per mole oxygen. The molar mass of oxygen is 16 grams. 2 times 16 equals 32 grams. So the molecular weight of oxygen, O2, is 32 grams per mole. The next example is water. Water is written as H2O. The molar mass of hydrogen is 1 gram, and of oxygen it is 16 grams. So together the molecular weight of water is 18 gram per mole. Next is glucose. Glucose is written as C6H12O6. Molar mass of carbon is 12 gram. When multiplied by 6, it is 72 grams. Likewise, 1 oxygen atom weighs 16 gram. When multiplied by 6, it is 96 grams. And each hydrogen atom weighs 1 gram. So in total, the molecular weight of glucose is 180 grams per mole. Next example is sodium chloride. The molar mass of sodium is 23 grams, and that of chloride is 35.45 grams. So, the molecular weight of sodium chloride is 58.4 grams per mole. Next example is potassium chloride. The molar mass of 1 mole of potassium is 39 grams, and that of chloride is 35.4 grams. The molecular weight of potassium chloride is 74.4 grams per mole. The next example is calcium chloride, which is CaCl2. Here, there is 1 calcium atom, and there are 2 chloride atoms. Molar mass of calcium is 40 grams, and of chloride is 35.45 grams multiplied by 2. So the molecular weight of calcium chloride is 110.9 grams per mole. Next example is calcium carbonate, which is CaCO3. The molar mass of calcium is 40 grams, and that of carbon is 12 grams, and of oxygen it is 16 grams. As there are 3 oxygen atoms, each one has a molar mass of 16 grams. So, when multiplied by 3, it will be 48 grams. So, in total, the molecular weight of calcium carbonate is 100.08 grams per mole. Next example is sodium bicarbonate, NaHCO3. As shown in the picture, you can see there are 3 oxygen molecules and 1 hydrogen molecule, 1 carbon, and 1 sodium molecule. When all of their molar masses are added, the total molecular weight we get is 84 grams per mole.